All right, let's talk about vector projection. So we don't always have a horizontal vector, but if we had two vectors and they weren't horizontal, you just turn them so that the vector you're projecting onto becomes horizontal. So I could have started with that blue and it actually just turned it so it became the purple. So in this case, I'm going to project vector u onto vector v. So v is, it's like with logs. So I'm projecting vector u onto vector v. So it's a subscript for the v. And what does that mean? It means so I'm going to, it's like a shadow. They always talk about a shadow. So vector u projected on vector v is just this section of vector v, right? So it's that vector there. Of course, vector u could have been, let's just put it over here for a second. If it was over here, when we project it onto vector v, it would be this vector. So it's just in the negative direction. It's not going to be in the same direction as vector v, but it will be parallel to vector v. All right, so you'll just get a negative there. But let's just deal with this one to start with. So, so you can see already that it's going to be some scale factor of vector v. And that's really all we have to know, because what I can do is have a look at vector v. Here's vector v, and look at its vector v's, if I take its unit vector, remember that's the unit vector of vector v, and then scale it, put something in front of it, scale it by some factor, then that's what I'm really after. So just remember how we do that. We take vector v and we divide it by its length, its magnitude, and that gives us the unit vector. Okay, so just remember that. So now let's look at the scalar that we want. So if you think about it, we just want that length. That will be our scalar length. How do we find that? Well, hopefully we've got this angle here. If we have that angle there, if you think about it, cos of that angle, can't always hide, will be the length of vector v on the length of vector u. Can't always hide, yep, that's right, because this of course is 90 degrees. So, and this is in terms of length. So if I want, yeah, and I shouldn't have said vector v there, should I? So the whole vector is vector v. So if I just want this bit here, let's call it a, I just want that length a, then I really should be saying I just want length a. Oops, there we go. I just want length a, that's what I want. So I can scale my unit vector v. So if I just rearrange that, what have I got? I've got magnitude of vector u cos theta. So then that gives me the projection of vector u onto vector v being this scalar length, so u cos theta, times by this, the unit vector v. So I could write it either way. I might write it this way. So a lot of times people just memorize a formula. So you can see, yeah, you can probably see why we would do that. But I like to keep doing this from kind of first principles, because it makes sense, and then if I forget in the exam a formula, I can still do it. So let me just go over it again. So I know I want some scalar of vector v. So it's in the direction of vector v, but I don't know its length. So I make vector v into a unit vector, and I put a scalar in front of it. What scalar do I want? Whatever this length is. How do I find that length? I just use right angle trig. But remember, when you do that, what you're doing is using distances. So cos theta is the distance a, which is that scalar part, over the distance of vector u. Rearranging that, my a, my scalar, is magnitude of u cos theta. So I've just got that in front of my vector v, but the unit vector of v. And that's how the projection of u onto v works. So shall we try one? Let's see. If I just rub all that working out, and we say we're given this. We are given vector u being 5i minus 12j, and vector v being 4i plus, I don't know why my eyes don't work, 3j, that is an I. And so if you want to kind of picture it, sometimes that helps. So if we go, that's going to be bad anyway. So let's go across 5 and down 12 and make that vector u down here. And across, what did I say, 5? That's 4 and up 3. So we'll go here for our vector v. So what are we going to project? Let's project vector v onto u this time. So v, if I think of v being projected on u, I need to think of u, this is a bad picture, as my horizontal, and then I'm projecting v down. So you can see it's just going to be this little vector here. So again, it's in the same direction as vector u. I need to know that scalar, how much to scale the unit vector up by. Alright, so really I need that, either I need the angle between them if I want to use this, which I can do. I can also use the fact that if I don't have the angle between them, remember I do know that u dot v is equal to u v cos theta. So if I want cos theta, or even if I want u cos theta, if I want this part, so I can just put it in for that part. Think about it, I just want u dot v, and I'm going to divide it by the length of v. So I could always do that as well, since we've got these. So well, let's have a look at what u dot v is equal to. So 5 fours, so we've got a 20 minus 12 threes, 36. And we're dividing that by, so that bit's minus 16, isn't it? We're dividing by that the length of v. Yes, is that what we're doing? Yeah, so there is a quicker way, but anyway, we're dividing by the length of v, and the length of v, you can see v's here, easy, 3, 4, 5. So that's going to be a 5 there. So I've got minus 16 on 5, so this is going to be, that's what I did wrong, because I was saying projection of u onto v. And I'm actually doing v onto u, so I really want the v cos theta. Oh, that's okay, I can quickly do that. That means I just need to swap that to a u, sorry. So that'll be 13, right? 5, 12, 13. So minus 6 on 13 is what I want. So I've got minus 16, sorry, did I say? Yeah, 16 on 13. And then I want the unit vector that I'm projecting onto. So u, I want this vector, but I want the unit vector. So if I look at the vector u, but make it a unit vector, so here's my vector u, 5i minus 12j, but I want to make that a unit vector, so I want to divide it by its length, which is 13, right, because again it's a 5, 12, 13. Alright, so what have I got here? I've got minus 16 on 13 squared, 169, of this vector 5i minus 12j. So using your calculator, you'll get some fraction. I hope that's right. 192 or 169. and that will be your projection there. So that's this little tiny bit vector here, just that little bit there. So that's doing it from basics, from the beginning, from, you know, without kind of remembering a formula. So if you want to remember a formula, you can. Just make sure you know how to do it from scratch as well. If you're remembering a formula, we would end up having the projection of v onto u being the u dot v on, so we just had it there, I should have left it there. Remember, we had that 13 squared on the bottom, and we have the vector, so the vector we're projecting onto, we have that vector, but we're dividing it by, so if I split that for a second, we're dividing it by its length to get the unit vector. And then remember, we had the u dot v, because u dot v is the same as u v cos theta, remember that, on the u, so those cancel, and we're timesing by that unit vector. So remember, we had that, so if we kind of put all that together, we get this formula here. So if you're going to remember a formula, u dot v on the magnitude of u, all squared, times by the vector that you're projecting onto. So just be careful whether we're doing projection of v onto u or u onto v. Of course, that will change up, so be careful if you're going to memorize a formula. All right, hope that helps.